wonderful students. I'm happy to have you back in class. You're welcome to Eko Learners Support for WAEC and NECO candidates. I hope you are beginning to catch up with your chemistry studies. Today's class is going to further help you to develop and be the superstar that you want to be. I remain your humble chemistry instructor, Jimo Rashid. Are you ready? Come on with me and see what we have in stock for today.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Today's class is a continuation of our previous lesson, which is on chemical combination. Remember that we have considered ionic and covalent bonding, and in another separate video, we also looked at coordinate covalent bonding. In today's class, we would be talking about metallic bonding. Yes, you're right. You heard me right. Metallic bonding, which is going to be telling us about so many things, why metals have the properties that they do have, what is actually the secret of metals. So, let's get going. I want you to write the topic down in your notes, metallic bonding, and the dates. We have set these objectives, and surely we would achieve them at the end of this class. 1. You should be able to define and explain metallic bonding after watching this video. 2. You should be able to state at least 3 physical properties of metals. 3. You should be able to apply the knowledge that you have acquired in this lesson to explain the properties of metals. Why do metals behave the way they behave? That answer should be provided by you at the end of this class. Let's look at some keywords that you will need to be able to understand this topic better. Dative bond, which we spoke about in our previous video. It is another name for coordinate covalent bond. Lone pair of electrons. This is an electron that has not been used for bonding. Sea of electrons. We are talking about cloud of electrons, which is usually what we have in metals. So let's get going. Let's inspire ourselves with these quotes. And it was given by Marty Stepanek, that very renowned poet. He said, "Unity is strength. When there is teamwork and collaboration, wonderful things can be achieved." You and I, we will be working as a team in this class, and we will be collaborating on a whole lot of activities. And I can assure you, wonderful things we are going to achieve. Let's get going. Of course, I'm sure you have a copy of your periodic table. So let's look at what we mean by metallic bonding. Now, metals are giant structure of atoms. That word is very important. Giant. Metals have giant structure, lattice. The atoms in a pure metal are in tightly packed layer, as you can see on the screen. They are closely packed together, and that gives a strong electrostatic force of attraction, okay, between the atoms. The outer electrons of the metal atom separate from the atoms and created a sea of electrons. One thing we know for sure about metals is their ability to lose electrons. So they normally lose their valence electrons. These valence electrons is usually in a form of cloud or sea round positively charged nuclei. And it is the attraction between the electrons and these positive atoms that result into what we call metallic bonding. Remember, you must use this expression, sea of electrons. Another alternative is for you to describe it as what? Cloud of electrons. So metallic bonding usually results whenever there is an attraction between the valence electrons of the metal forming delocalized sea of electrons which are strongly attracted to the positive ion. These electrons are delocalized. What do we mean by delocalized? The root word is locate, where you can find something. When something delocates, it means that that thing is not fixed in a particular position. So these electrons are not fixed at any point. Instead, they are hovering around the positive ion. This is what we mean by delocalized electrons. The metal atoms become positively charged ions and they are attracted to this sea of electrons. This strong attraction is what we refer to as what? Metallic bonding. Now you can now understand the reason why metals have some of the properties that they have. Let's march on. These are examples of metallic bonds that you can see clearly there. An example of metal is copper, which is used in electric cable. It's strong, it's a good conductor of electricity, it's ductile, okay? Steel, very strong in construction, is malleable, you can beat it into sheets. Silver coin is lustrous appearance, very, very attractive. How about gold jewelries? Now, these are different properties of metals, and you can see reason why metals are so useful. Now, look at that. How does the sea of electrons affect the properties of metals? You can see the electrons there. They are hovering around, okay? So that's what we call the sea. The electrons are playing there. They are delocalized. They are not fixed in any particular location, and the attraction between them and the positive ion of the metal results into what we call metallic bonding. You can see the electrons are close. Oh, it's packed in here, telling you that the electrons are tightly packed. That is a strong attraction. Metallic bond is actually a strong bond. I believe you're finding this class very, very enjoyable. Now, what you can see there is a molten gold. When gold is melted, the melting point of gold is close to 2000 degrees Celsius, telling you how strong the force of attraction is. So you need a lot of energy to what? To break them down. And you can see in the furnace, they have to heat gold to such very high temperature before it can give way and what? And become molten. You can see the boiling point is 2,807. The melting point is 1,064. That's a whole lot. That's a whole lot. You need a lot of energy to be able to do that. This property is due to the what? The strong attraction between the positively charged metal ions, and of course, we can never overemphasize the sea of electrons. Okay? In metal extraction and other industrial processes, furnaces often run continuously to maintain the high temperatures needed to work with molten metals. Wow. Let's now look at some of these properties that metals have. The first one is malleability. Can you repeat that? Yes, malleability. Malleability is derived from the word hammer. Hammer. When you hit a solid, okay, metals are usually strong, but they are not brittle. Means that when force is applied on them, they can slide over each other. They can slide, and that can make them to what? To be bent, to be beaten into sheets. You will see in construction, in building of the car's body, aircraft bodies, you will see metals actually beaten down into thin sheets. This is as a result of the property that we call malleability. Can you say that again? Malleability. Let's keep going. Okay, so you can see this is what the metal atom looked like before the heat, and this is what happens after the heating, telling you that they can actually slide over one another. The metallic bonds do not break. No, metals are so strong that they will not break apart from each other, but they will slide, okay? Because the delocalized electrons are free to move through the structure. All right, another property is that metals are good conductors of heat. Let me ask you, the pot that you use to cook at home, what material is it made of? It can be rubber, it can be plastic, it can be wood. Why? Because these are poor conductors of what? Of heat. They are made of metals. Metals like zinc, metals like tin, okay, aluminum, because they can absorb heat. So delocalized electron is responsible for this property, okay? It allows metal to conduct heat as well as what? Electricity. And you can see that, for example, when metal is heated, delocalized electron does what? It gains kinetic energy. Kinetic energy refers to energy in motion. So they absorb kinetic energy, and so they are able to move. The electrons then move faster and transfer the gained energy throughout the metal. You will see that over time, the pot begins to become hot at every given point. When you start, it is just the bottom, but it absorbs the heat until the entire space of the pot becomes what? Hot. It's because the electrons are what? They are delocalized and they are moving faster, and that's how you feel the heat there. Wow, this makes heat transfer in metals to be what? To be very efficient. All right, how about conduction of electricity? This is very intriguing because if you look at the way the metals are able to conduct electricity, it's more or less like, you know, pass it to me, I pass it to you. They keep exchanging, they keep passing the electrons, and that's why if you have an electric cable plugged to a socket on one hand, if you hold it at the other hand, you're going to do what? Experience electric shock. How? Why? It's because the electrons are going to flow. It's a conductor. It allows electrons what? To flow. It's just like the bus conductor. It allows you to go into the bus. So metals also allow electrons to what? To flow. And if you stand in their way, the electron flows into you. You can see, pass to me, pass, 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 until the electron is able to flow through delocalized electrons again. And I have explained to you what delocalized electron means. It means that the electrons are able to what? To pass through the metal in a similar way that we have explained with the conduction of heat. I'm sure that you have sufficient knowledge to now be able to tackle the top exam question. Are you ready? I need you to breathe in, breathe out. Breathe in, breathe out. Now I believe you are ready. Come with me. The first question says, what is responsible for metallic bonding? I don't expect you to miss this. We have given sufficient knowledge, sufficient information during the lesson. A, sharing of electrons between the metal atom. B, attraction between the atomic nuclei and cloud of electrons. C, transfer of electrons from one atom to another. And D, attraction between positive and negative ions. Did you find these options confusing? Which one do you think is the correct option? I know you will eventually get it. You are right. The correct option is option B. I'm sure if you miss anything at all in the class, you will never miss the what? The C of electrons. The C of electrons. Let's get back to the question. And I said another name for it is what? The cloud of electrons. So that's what is responsible, the attraction between the atomic nuclei and the sea of electrons. Let's look at this. Are these statements about metallic bonding true or false? All right? So I need you to have 2 sheets of paper. On one, write true on it. On the other one, write false. I'll read the question to you. If you think the answer is true, you raise the paper indicating true. If you think the answer is false, you raise the other one where you have written false. Are you ready? Do you still need to breathe in and breathe out? I'm sure you are ready. Let's go. All right, the first one says metals have a lattice structure. So which of the paper are you raising? Is it the true or the false? What do you think? Metals have a lattice structure. What we mean by lattice structure is a regular arrangement of atoms. And if you look at the first statement we made at the beginning of the class, we talked about metal having giant lattice structure. So the answer to that is true. I'm going to be using T for true and F for false. Metallic bonding is an attraction between metal ions. It's an attraction between two metal ions. Is that true or false? Yes, you are right. That is false. It is an attraction between a metal atom and the what? And the C of the localized electron. So that is false there. 3, electrons have fixed places in the sea of electrons. Now, you have to be careful about that word. They have fixed places. Do you think the electrons are fixed? If they are fixed, then why are we talking about delocalization? So you can see the examiner is trying to what? Trying to see whether you truly understand this thing deeply. Okay? And that means the answer is false because the electrons are not fixed. They are able to move. Number 4, metallic bonding allows metals to conduct electricity. I don't expect you to blink before you are able to raise that paper. Now, which one? Correct. Fabulous. You're really getting good at chemistry. You're wonderful. That is true. Metallic bonding allows metals to be bent. Metallic bonding allows metal to be bent. Is that really correct? Do you think metals can be bent? What do you think? We talk about malleability, beaten into shape. Does that translate to being bent? I was just trying to play. That is also true. You can beat them, okay, into shape. And the last one, metallic bonding lowers the melting point of metals. Is this true? No, it is not. You saw gold earlier on having a melting point of about 1064 degrees Celsius. Metallic bonding usually gives metals their high melting points. The correct answer here is false. So how many of these did you get correctly? Well done for the efforts, and I'm really, really proud of you. We have now come to the end of today's class. I have enjoyed it, and I believe that you have also found it very fun and interesting.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Until another time, when I come to the class, I enjoy you to leave your feedback, your suggestions. They are very valuable to us because it keeps us on our toes to be able to do more for you. Use the link that is displayed right now on the screen. Bye, and God bless you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.